Yeah, those who have joined, just wait for 5 minutes. I'm waiting for the other people who have to join. Okay?
Yes, sir.
Yeah. Yeah, welcome to the FDP. I can see 1, 2, 3, 4, 5, 6, 7 have joined. I think some more people have to join. I was waiting for other people. So we'll start as and when they come, I will admit them in the session. Who is this Saurav Das?
Sir, this is Lucy Patel. Actually, I have some technical issue with my email ID, so I joined using my
Okay. I was you are Lucy Patel. Okay. I was surprising because there was no name of this. Okay, no problem. Yeah. So let us start directly without wasting any time. So the first thing that we'll be talking about is what exactly is cluster analysis. Okay. So let me share my screen. Do you have any idea? Any of you, do you have any idea what exactly cluster analysis is about? Any of you? What is this technique of cluster analysis about? You can see my screen now, all of you?
Yes, sir.
Yeah. So just any of you, have any idea what is this technique about?
It is about gathering same type of object together.
Yes, it is about increasing or creating the making the segments in the market or grouping people together. So we have a very important concept that we have seen in marketing, which you often, who have done marketing management, have heard of that concept called as segmentation, targeting, positioning, STP. Now, when you are doing the segmentation, targeting, positioning, the first step in that is making the segments. So exactly that's what cluster analysis helps you to do, finding out the segments in the market, the segments of customers in the market. Making those segments is made possible by using the technique of cluster analysis. So that's what is cluster analysis about. So if you look at cluster analysis, it's a technique which is used to classify the objects or cases. Objects of cases are basically the people, the respondents in a survey, you can say in that way, into homogeneous groups which are called clusters or segments. So basically the people who are similar to each other will come into one cluster, and the people who are dissimilar to each other will come under the another cluster. So in this way, clusters or segments or groups are made. But there are two other fancy names of cluster analysis. It is also known as classification analysis, and another name for it is numerical taxonomy. So sometimes people want to give out some stylish names. You can say, I'm not doing cluster analysis, I'm doing numerical taxonomy. So you have a stylish way of saying that I'm doing numerical taxonomy for my data. So cluster analysis, some simple terms which are there. Each of these terms, again, I will explain to you as and when I will do the analysis, because as there are some people who were there in my previous session, they know that it will not be any theoretical session, it will be completely hands-on. So I will go to, in next 5 minutes, I will go to SPSS and start telling you or showing you how to run it. So each of these terms are there in such analysis. As and when we run it, we will be explaining each of these terms individually, how it is formed or how it is used or where it is the use or what is the use of each of these techniques, terms. Cluster analysis has certain methods or steps, you can say. You need to find out what exactly is the segment or problem that you are going to solve. Select a distance measure, select a procedure, decide on the number of clusters, interpret and profile, and assess the validity. These are some of the ways, these are the steps of conducting cluster analysis. So we will be talking of each of these steps one by one as and when we run. So without wasting time, I will go straight to the data which I've already shared with you, and that data will run the cluster analysis on that, and then explain each and every part of the cluster analysis. So yeah, let me go to the data. Yes, this is the data file I have sent to you. So this is a small data point of 20 people, and they have collected, the data is collected on a Likert scale, and it is talking about shopping behavior of people. So the items which were used are the questions which were there in the survey were: shopping is fun, shopping is bad for budget, shopping is combined with eating out, I always look at best buys or offers when shopping, I don't care about shopping, and I always compare prices while shopping. So each of these questions people have responded on a scale of 1 to 7. And besides that, also we have collected 2 more demographic data, age and gender. Simple data to run the analysis. So I'll run the analysis, and then before running the analysis, there are 3 methods of cluster analysis, and they are known as hierarchical method, non-hierarchical method, and 2-step method. So each of these has a separate use, how and where, as we run the methods that we will tell you. The first method of running cluster analysis is always hierarchical analysis, and we will run it. The first technique that we will use is this. So we'll go to analyze, then we go to classify, and then we'll go to hierarchical cluster analysis. Everyone is able to follow what I'm doing? Anywhere you are not able to follow, or anywhere you are not confused, or any doubts you have in between, you can stop and ask me. Okay, so analyze, classify, hierarchical cluster analysis. Now in this, we'll take these Likert scale variables 1 to 6 in the variables column. And after we take that, we'll go to statistics, and in that the thing that we'll put on, everything else what is there is fine. Now this range of solutions is you have to put it. Now there are 20 people in this group, so we have to make groups or segments. At least 2 segments you need to make, or 2 clusters you make to make. So that is the minimum. And if there are 20 people, maximum you can go for 4 clusters, because if you go more than that, there will be very less number of people in that segments, and that does not make sense. So maximum we can go for 4. So that range of solutions, how many clusters you want to check for, you need to decide finally which is the ideal number of clusters, segments or groups. But for deciding that, you will need to run a range of solutions. So we'll have 2 to 4. So we'll check for 2 clusters, 3 clusters, and 4 clusters. And then we will decide based on certain criteria what is the ideal number of groups, clusters, or segments. So in this range of solution, we pick 2 to 4 and click on continue. Go to plots and click on this dendrogram. Nothing else is needed. And click on continue. Go to method. There is a distance measure. This is called the interval measure, which is by default squared Euclidean distance, which we will use. And then there is a clustering method. There are different types of methods. There is nearest neighbor, there is between groups, farthest neighbors. But the most commonly used method is this method, which is a variance-based method called as Ward's method. So we'll use that. So change that to Ward's method. Distance is by default squared Euclidean distance, and click on continue. And then go to save, the last button. And again here also the range of solutions that you are talking of, 2 to 4, you put. And click on continue. Nothing else. After you've done that, click on OK. So the output will come now. So I will share the output. Yeah. So this is the output. Everyone can see the output. Any doubts till now? How we have run it? Any questions? Any doubts? Yeah. So we'll go forward.
So,
Yeah, tell me.
sir, why didn't we check proximity matrix?
No need. You don't need it. You are saying about this proximity, na? That is not needed. For interpretation and using, it is not at all needed. Okay. So now we go to this first thing that we check out in the output is this cluster membership.
Sir?
Yes, Akash.
So it is dependent on the which kind of calculation method we are selecting. It's words or
Yeah. Yeah, it may change, may not change. If there is a change also, very slight change will be there, not much of change. But the most commonly used and the safe method to use is Watts method because that will give you the best solution always. Because it's a variance based method.
Okay.
In many multi-variate analysis, variance based methods are always the best ones. Yeah. So, yeah, let us go to this first thing that we need to check is this. You look at this cluster membership. Now you see that if there are 4 clusters, segments or groups are formed, in that case, it is showing which respondent or which person will be falling under which group. If you look at these 4 clusters, you see in cluster 1, there is respondent number 1, 3, 6, 7, 8, 12, 15, and 17. So 8 people are grouped in cluster number 1. Similarly, in cluster number 2, 1, that is respondent number 2, respondent number 5, respondent 9, 11, 13, and 20. So 6 people are grouped under cluster number 2. In cluster number 3, we have respondent number 4, 10, 14, 16, and 19. So 5 persons are there in cluster or segment or group number 3. And if you look at cluster number 4, there is only 1 person, that is respondent number 18, which is there. So looking at this itself, we can rule out the 4 cluster solution, because if we get a segment with only 1%, there is no point of having that type of cluster or segments. So 4 cluster solution is not an ideal solution. Now come to the next one, 3 cluster solution. So everything is same. Cluster 1 has 8 respondents. Cluster 2 has 6 respondents. And you can see now that the respondent who was in 4 is grouped into 3. So again, cluster 3 has 6 respondents. Look at this one. So we have 8, 6, and 6. A very fairly good distribution of people into 3 different clusters or segments. Now, looking at the 2 cluster solution. If you see, those who are in segment 1 or cluster 1 are still in cluster 1. Those who are in 2 and 3 have been grouped together under 1 cluster. So now we have 2 clusters, 8 under cluster 1 and 12 under cluster 2. Now the question comes. See, 8 and 12 and 8, 6, 6, both looks a quite feasible and logical solution. So which one is a better one? Is it the 3 clusters or is it the 2 clusters? Which one will be your ideal solution? That you have to decide from this hierarchical cluster method. And to decide that, we look at this particular table called as agglomeration schedule. Now, where you see, it is showing how the clusters are made. How these clusters are made, I will explain to you later. But what we need to understand is that the first stage is when respondent 14 and 16 has been put together in one group and the rest 18 are separate cluster. We start with 20 different people into 20 different clusters and then go on combining them. The first step is when we have 19 clusters, that is 14 and 16 under one cluster and rest 18 as separate clusters. In the second stage, 6 and 7 has been grouped again. So now we are having 18 clusters. So in this way, it goes down from 19, 18, 17, 16 till the last step where we have one cluster, everyone combined into one cluster. So you will see when you have this agglomeration schedule, you will always see the stage is one less than the number of respondents, because we start with, if there are n respondents in your data, we start with n minus 1 cluster and end up at 1 cluster. So since there are 20 people, we are having started with 19 clusters and last we stopped at 1 clusters. Now this table is help you to decide which is your ideal solution. If you look at this coefficients column, it shows as the distance where the people have been joined to make the clusters. So last 3 steps, that is 17, this is the 3 cluster solution. 18 is 2 cluster solution, 19 is single cluster solution. Now look at these jumps from previous stage to next stage. This will help you to decide which is your ideal solution. We always look at the last 3 or 4 stages. So if you look at these stages, 64.5 to 79.66, then 79.66 to 172, and 172 to 328, where do you think is the highest percentage jump has happened? Can anybody tell me? Look at only last 3-4 stages. You don't need to look at any of them, other stages. Where do you think the highest percentage jump has happened?
Stage 17 and 18.
Yes, exactly. So stage 17 to stage 18 has the highest jump percentage wise. Though the absolute value it is 18 to 19, but percentage wise highest jump is 17 to 18. That is from 3 cluster. Yes.
So why are we taking n minus 1 to n? Why not n to 1? Like the stage.
No, n cannot be enough. N we cannot show, because the first stage we show is when at least 2 respondents have been grouped. So this is the first stage where 14 and 16 respondent has been grouped into one and the rest 18 are separate clusters. That's why. The first stage, if you take n, it is basically all 20 are different clusters. So it cannot be shown in this table. Na? We will stage at a step when at least 2 respondents are grouped together. And how they are grouped together, that is the method, is this squared Euclidean distance we have talked about. So what we do is we calculate the mean value of all the 6 variables which we are there in this case, and the mean value of for each respondents, and see where is the distance closest to each other. So those 2 people are grouped, and in this way you go on till we get a single cluster. We go on grouping. So because we start with 19 clusters, because there are 20 respondents, the first stage is when you have combined 2 persons in one group and rest 18 and 7 separate clusters. That's why we start with 19 or n minus 1. Similarly, next stage is when you have combined 14 and 16 already combined, 6 and 2nd is already combined. And so we have raised 16 as separate clusters. So you have 18 clusters. So in this way, 19, 18, 17. I'll show you how this is made. I'll explain that to you. But first, let me tell you this 79 to 172, how this ideal solution is to be done. How this grouping is made, I will explain it in details. If you look at this 79 to 172, this is the highest jump. That is from 3 cluster solution to 2 cluster solution, the jump is highest. So my ideal cluster or ideal number of clusters as per this is 3 clusters. Any doubts till now? So when the jump is highest from X to X plus 1 stage, the stage X is your ideal number of solution. So since the jump is highest from stage 17 to stage 18, that is from 3 cluster to 2 cluster solution, stage 17 or 3 cluster solution is your ideal number of clusters. That is 3 clusters with 6, 6 and 8 respondents in those 3 clusters. Yeah. Any doubts?
Sir, I am trying to use the same data set in SPSS, but I'm not getting the output as similar to yours.
What you have done?
It's exactly the same process that you have.
No, you have used hierarchical cluster analysis.
Yes, hierarchical cluster analysis.
Okay. So you have to go to this hierarchical cluster analysis. You have to select only the variables. Have you selected this age and gender also?
No, sir. I selected only the variables.
V1 to V6.
Yes, V6.
V1 to V6, all the 6.
Yes, V1 to V6.
Yeah.
Sir,
In statistics, you have given the range of solution as 2 to 4.
yes, sir. 2 to 4.
Okay. Plots, you have got dendrogram.
Sir, I think I got my mistake. I only put 5 variables over there.
That's why. That's what. That's why if you have followed the same procedure, it cannot have a different result. Yeah.
Thank you, sir.
Yeah. This ideal number of solution, is this clear or not? Which is the ideal number of cluster segments of group is decided on this jump, percentage highest wise highest jump. So is this clear or not? Anybody having any doubt here?
No, sir.
Everybody is crystal clear? Yeah.
No, sir.
So the ideal number of solution is 3 cluster solution, that is 29 to 172 is percentage jump. Now this same thing is also possible, but because the number of respondents is less, it is easy to understand. But this diagrammatically the same thing is showing at this same thing. So if you look at this, this is showing how the respondents are grouped. So you have these 3 cluster solution here. This is cluster 1 with 1, 2, 3, 4, 5, 6 people, 8 people under this cluster. 6 people, sorry. This is cluster number 2, which is cluster number 1 is this respondent number 14, 16, 10, 4, 19, and 18 are under cluster 1. Under cluster 2, we have 2, 13, 5, 11, 9, and 20. That's 6. And under cluster 3, we have 3, 8, 6, 7, 12, 1, 17, and 15, 8. 6, 6, 8. Now, if you go from this cluster, which is 1, 2, and 3. Now, 2 cluster is this. When you have seen those 2 clusters have been combined. So we have 8 and 2 under this. Now, look at this distance. Measure from left to right. Now, this is where the 3 cluster has been formed. So this is approximately around 3 in this scale, and it ends at 15. And this is where the 2 cluster has been formed. So 15 to 25. So which one is higher distance? 3 to 15 or 15 to 25? Which one is higher? Can anybody tell me?
Best of 3.
3 to 15. That is 3 clusters. 3 to 15 is higher because it is 12. This is 15 to 25, 10. With the same logic, from 3 to 2, this is the highest percentage jump, 79 to 172. This is the distance at which the clusters are formed. 3 cluster is your ideal solution. So always you need to look at this distance from left to right. Which one is higher will give you the ideal solution. So 3 to 15 is 12, 15 to 25 is 10. 3 to 15 is for 3 cluster solution. So 3 cluster is your ideal solution. The same thing which is shown is agglomeration schedule mathematically in that table is shown diagrammatically, because that coefficient column or this distance is basically the distance at which the clusters are combined. So the higher the distance at which the clusters are combined, so you need to stop at that distance. When you are combining at a larger distance, that you need to look at and that you need to decide. So this is the ideal number of clusters. That's what we look at. Now, if you look at this now, let us look at this agglomeration schedule in details and let us explain how these clusters are formed. That's what we need to explain now, or I will explain. Give me a second.
Sir, what was the last statement that you said?
I will tell you I will explain to you the agglomeration schedule and how the clusters are formed. Just let me share the screen and I'll show you how. Now, this is the same agglomeration schedule I have looked at this. You can see the screen.
Yes, sir.
So we'll look at this table now. See, the first stage is where respondent number 14 and respondent number 16 has been combined into one clusters, and rest 18 are separate clusters. So we have 19 clusters. Second stage, 6 and 7 has been combined. So how many clusters we have? We have 18 clusters. One cluster is 14 and 16 together. Second is 6 and 7 together. Rest 16 are separate clusters. After that, in the third stage, we have combined 2 and 13 respondent. So now we have 18 clusters, is 17 clusters. One is 14, 16, another is 6, 7, another is 2, 13, and the rest 14 are separate clusters. Fourth stage, 5 and 11 has combined. And so we have how many clusters? 16 clusters. One is 14, 16. Second is 6 and 7. Third is 2 and 13. Fourth is 5 and 11. And rest 12 are single clusters. Fifth stage, 3 and 8 has combined. Just one second. Yeah. Next stage is 3 and 8 combined. So if you look at this 3 and 8 combination, now how many clusters we have? We have 5 groups, which are 14, 16, 6, 7, 2, 13, 5, 11, 3, 8. And we have the rest 10 as separate clusters, 15 clusters. Come to the 6th stage. How it is it showing? 10 and 14. 14 is already in this group. So now respondent number 10 is added to this group. Come to the 7th stage. 12 and 6. 6 is already in this group. Respondent number 12 is added to this cluster or group. 8th stage, 9 and 20. Neither 9 is there, neither 20 is there. So a new group or cluster is formed. Next stage, see 4 and 10. Already 10 is in their group, so 4 is added to that group. 10th stage, 1 and 6. 6 is already here. So 1 is added to that group. Next stage, 5 and 9. See, 5 is in this group, 9 is in group. So we need to join these two groups. Then you see 4 and 19. 4 is already here. 19 will join that group. Next, 1 and 17. 1 is in this group. 17 will join that. And next again 1 and 15. So again 15 will join this group. Then 2 and 5. 2 is in this group. 5 is in this group. So now we can join these two groups. And then 1 and 3. 1 in this group, 3 is in this group. So we are again joining these two groups. 4 and 18. 4 is in this group, 18 will join this group. So we'll stop here because 3 cluster or 17th stage is your ideal solution. And now we can see these are the groups you have made. First group is having respondent 14, 16, 10, 4, 19 and 18 in that cluster. 6 people. Second group having 6, 7, 12, 1, 17, 15, 3 and 8 in second cluster or second group. Third is 2, 13, 5, 11, 9 and 20. So this is exactly what is being shown in that agglomeration schedule, step by step, how the groups or clusters are formed step by step by combining one person at every step and making or adding the groups or making the groups. Had the two cluster solution be the ideal solution, then these two groups, this group and this group would have been joined, and so now two groups would have been 12 and 8. But since we have a 3 cluster solution as the ideal solution, we are stopping here and we can clearly see 6, 6 and 8. Any doubts here how it is being made? How the groups are formed? How the clusters are formed? It is clearly showing in the agglomeration schedule. Any doubts here? Anybody?
Sir,
Yes, tell me. Hello?
no doubts.
Okay, fine. Yeah. So let us come back to the SPSS again. Now the output that we have seen as one more thing, which is the same agglomeration schedule, how the clusters are formed, are shown in this particular chart or diagram called as icicle plot. This looks at icicles, and that's why we call it an icicle plot. Now this also shows the same stages. The first stage where 14 and 16 have been combined. Second stage where 6 and 7 has been combined. So look at this icicle plot. First stage is when 14 and 16 have been combined and you have 19 clusters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Second step was 6 and 7. These two have been combined. So at that stage, you have 18 clusters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Third stage was 2 and 13. So 2 and 13 was combining here. So the same stage, as you go from below to top, is an inverted diagram, which is showing agglomeration schedule, how the clusters are formed step by step, is shown in this diagram also. Only it is diagrammatically presenting the same concept of agglomeration schedule, the first two stages, 14, 16, 6, 7, how this is formed. And also, if you go to the data file, since we selected save option, in the data file also, you will see the same cluster solution is saved. So if you look at this, you can see this is the 4 cluster solution, this is the 3 cluster solution, this is the 2 cluster solution. But for us, this is the only interesting part, which is the 3 cluster solution. It is showing the same results that we have got. Which respondent is under which cluster, it is showing. Till now, is everything clear? Then we'll go to the next step, that is non-hierarchical cluster analysis. Any doubts on anything till now? Anybody? Starting from the data file to any of these steps, any of the interpretation, anything. Is there any doubt?
Sir, in agglomeration schedule output, we had a last column named next stage. Can you explain that?
That is showing. Yeah, I told you. Yeah, that is showing. When is the next stage? This is another member is added to the group. See, first stage 14 and 16 has made a group. So when is the next member added to the same group? You go to the stage number 6. You see 10 is added to that same group. Similarly, 6 and 7 is this joined to make a group or cluster. Again, in the same group, another member is joined in the 7th stage. That is, you can see 12 has been added to that group. So this next stage is showing when is the next stage or next step where another member is added to the group and the group is increased. Clear?
Yes, sir.
Yeah. So if there is any other doubt or no other doubt, then we'll go to the next method of clustering, that is non-hierarchical clustering. Okay. So we'll go to the next method, which is known as non-hierarchical clustering, or another name for non-hierarchical clustering is K-means clusters. Now, that is the second stage. We always start with hierarchical clustering and then follow it up with K-means clustering. What is the reason? The reason is in K-means clustering, you need to decide or give what exactly is the number of clusters. So basically what happens is, when you don't know what is your ideal number of solution, you do hierarchical clustering, get an idea by looking at that jump in the agglomeration schedule, which is your ideal number of clusters, in this case, which is 3, and then confirm it or cross-check it by using the non-hierarchical clustering or K-means clustering. Because here you cannot determine through the method what is the number of clusters, but you have to give at the start, this is the number of clusters that you want to make out of this data. So number of clusters is 3 we have got from hierarchical clustering. We cross check it using the non-hierarchical clustering. So number of clusters you put 3, and the variables, just like before, the all V1 to V6 you put in the variables box. Go to save option and this cluster membership. Continue. You can go to this options option and cluster information for each case. These are the 2 buttons you need to check, nothing else. Save option, cluster membership, options option, cluster membership for each case, and change the number of clusters for the number of clusters or solution that you want to check for. So in this case, this is 3. So let us go to this next one. So after you have done this, just click on OK, you will get the output. So this is the output which comes under, which is called as quick cluster. So you'll get that output. So in this, you can see there is something called as initial cluster centers. This is not needed. This is basically, this is an iterative procedure. So to have an iterative procedure, you need a random starting point. So say I picked up random starting point from the data and started the iteration. So this is the random starting point. This is not relevant to you. What is relevant to you will be your final cluster center, which I will explain what it is. But here you can check how many clusters are formed. You can see it will directly show you. It is forming cluster number 1, 6 people, 2 with 6 people, 3 with 8 people, exactly the same. 6, 6 and 8, but we have got with hierarchical cluster. Exactly same. Now are the same people in the same clusters? Let us go and check in the data file. See, now you look at the data file. This is the 3 cluster solution from hierarchical clustering. This is the k-means clustering solution. Just look at the data and see, are the same people in the same group? Just let me know. Looking at the data, what do you understand or what are you getting? Are the same people still in the same group?
Sir, same. It's same, but only the cluster names are different.
Yeah, cluster
One
name or number has changed. The taxonomy has changed basically, name or number, but it is the exactly same people. 1 and 3 has exchanged the number or name of the cluster. But if you look at this, 2, 1 and 3, it is the same 6, 6 and 8 people in the 3 clusters. Only 1 and 3 has exchanged themselves as the name of the cluster. And so it is the same 6, 6 and 8 solutions that you have got. The solution is same for both the clusters. But this may not be the case in sometimes in real life data when you are collecting the data through a survey. You may not get the same exact solution by using hierarchical and non-hierarchical or k-means cluster. As long as the difference in the groups, if some of them has changed groups, as long as the difference is within 20% of the total data, you can still go ahead and interpret the results. There is no problem in that. So you may not get exactly the same number of people in the same number of segments or same result from both the methods. In this case, they are exactly same. Now look at this final cluster centers. That is an important part. This is a very important part, final cluster center. What it shows the average value or the mean value or that variable for the respondents in that clusters. So if cluster 1 has 6 people, whatever responses they have given in that Likert scale in your data, the mean value of those people in that group is shown from that. I'll show you how. Just remember, for fun, the cluster center value, it is the another name for cluster center value is cluster centroids, is 4. For cluster 2 it is 2, and plus cluster 3 it is 6. Let us go to the data file again. 4, 2 and 6. Now if you look at these 3 clusters, yeah. Who are the people who are in cluster 1? This person. Then this. Just let me shorten it. Then this, this, and this. Now look at the values of V1 for these 6 people who are in cluster 1. 4, 3, 4, 3, 3, 4. So add them. 4, 3, 7 plus 4, 11 plus 3, 14 plus 3, 17 plus 4, 21. 21 divided by 6, which is 3.5, rounded off to 4. So it is, again, I am repeating, it is the centroid values or the cluster center values is basically the mean value for that variable for all the respondents in that cluster. For the second cluster, the same mean value or the cluster center value was 2. Now let us look at the people who are in cluster 2. Sorry. So now look at the value 2 plus 1, 3 plus 2, 5 plus 1, 6 plus 2, 8 plus 2, 10. 10 divided by 6 is 1.7, rounded off to the value was showing as 2. And the third one was showing a value of 6. So let us look at the third cluster. Six plus 7, 13, 19, 24, 31, 36, 42, or 4, 46. 46 divided by 8 is 7.6 something, which is round 5.6 something, which is rounded up to 6. So the same results were showing in that cluster center values. It is showing 4, 2, and 6. Similarly, for the next variables, you can similarly calculate the cluster center values or cluster center and values. And this is showing the mean value. Again, I'm repeating, this is showing the mean value of that variable for all the respondents in that cluster. So it is the center point of that cluster for that variable, you can say. That's why it is called as cluster center or cluster centroids. Clear till now or not?
Yes, sir.
What is this cluster center and what are the cluster values and how many clusters are made? 6, 6, and 8 in this case, cluster center values. Cluster center values are a very, very important application. What will this be the application? We'll come to it, but that has a very, very important part to play. We'll come to it, but before that, we'll look at the third
Can
method.
you iteration history in the output?
It is nothing, but it is showing how much it has, how many iterations and how much has been made in the basically to make those clusters, because it's an iterative procedure, no?
But what are these values interpreting?
It is showing the distances. They have talked about iterations and they have tried to find out different permutation combinations and differences in which these are made. Nothing. This does not have anything to do with you. You don't have to interpret or anything.
An initial cluster center? What does
Initial
that
cluster
tell?
center is the random starting point, which is the start of iteration, but that has not to be interpreted. What you need to interpret is this only, the final cluster center. After
The
the
manual
cluster,
interpretation means how, if we are planning to do it manually for a small data set, then how can we do it?
no, manually nothing can be done. No? You have to run it through SPSS. Manually,
Okay,
how
sir.
you do? Oh, you are saying for the calculation of the cluster centers?
Yes, sir. Like we can, if we could calculate it manually, what is the mathematics behind how these numbers came?
I showed you no, in the data tile. It is the average value of all the variable, for all the respondents for that variable in that data file, in that cluster. That's what I showed you in the table, na? When you look at this table.
Yes, sir. I understood. But, you showed for final cluster, no? Okay.
Final cluster centers.
And I was asking for initial cluster
It
center.
is not. It is not any calculation. It is randomly when one data point has been picked. It is not calculated. There is no calculation in initial cluster centers. Randomly, for each variable, they have picked up one data point from this data set. We don't know where is exactly, but randomly they have picked up. So there is no calculation in that.
Okay, sir.
The calculation is there only in the final cluster center, and interpretation is only there in the final cluster center, which is nothing else. Again, I'm repeating, it is the mean value for that variable for all the respondents or people in that cluster. That's exactly what it is. The final cluster center is about. And another name for it is cluster centroids. So we'll come to the third method.
Sir,
Yeah, tell me.
cluster membership.
What?
Cluster
Not able to.
membership.
Okay, this is showing which respondent is coming under which clusters. That is what it is showing. Which respondent is coming under which cluster, which is again shown in the input file also. We have saved that data. In the input file, we have saved that data already. This is showing which member is coming under which cluster based on these distance measures. And if you look at the input file, the same data is already saved. This is showing the same thing. Which member under which cluster. Clear?
Yes, sir.
Yeah. So let us come to the third method. So third method is known as two-step cluster analysis. This is a method which is used, but not that much. The use of number, this is has reduced, you can say. So we'll go to analyze, classify, and you can see there is something called as two-step cluster. So you take all those V1 to V6 under continuous variables. and just go to output. Sorry, output, and click on these two tables called pivot tables and create cluster member variable. Nothing else. Click on these two. Click on continue. And you need to change the distance measure to Euclidean and the clustering criterion as AIC. This is to Euclidean, this is AIC. And the maximum number of clusters, because there are only 20 respondents.
What is AIC?
It's a method which is there is a formula behind it. It will help you to decide which is the ideal number of clusters in this two-step clustering method. I'll show you once we get the output. Where is the use? Okay. Now determine automatically. You have only 20%. No point in having 15 clusters. You reduce it to 6 maximum. So nothing else. Output all the 3 checkboxes. Euclidean here, AIC here, and reduce the automatically to 6 and click on OK. Now you see the AIC will help you to decide which is your ideal solution. Look at this table called as auto clustering. And where do you see the lowest value? Where is the lowest value? In that AIC column, where is the lowest value? Can anybody tell me?
Sir, what did you just say?
In the auto clustering table, you can see that screen, na? Auto clustering table.
Yes.
Which is the lowest value for AIC?
Minus 3.577.
AIC, not change. The absolute value of AIC. It is for which number of clusters?
3.
Yes. So that is the ideal number of solution. So as per two-step clusters, also it is showing that 3 cluster is the ideal solution. Yeah, tell me.
Can you please repeat this 2 clustering process once again, because I am doing it on SPSS, but I'm not getting this output which is on the screen. I'm only getting 2 model summary and cluster quality as an output.
Then you need to put on, you have not selected all the steps. You need to go for this output, pivot tables, charts and tables, and create. All these 3 should be there. And then you need to check the Euclidean and AIC here and reduce the number of clusters to 6. And then you click on OK. You will get these results.
Sir, this we have to do on the data or the output tables?
On the data only. When you analyze it, it will take from the data table only. Even if the output table is open, there is no problem. It will show you, it will get the data only. There is nothing can be done on the output table. It only gives you the output. Got the results? What I have got?
1 minute, sir.
So if you look at these results, the lowest value of AIC will help you to decide which is the ideal number of clusters, which is 97.594 here. And that is again 3 number of clusters.
Their output is different from yours.
How to? Hello?
I just did everything in the SPSS and I'm not getting this output.
No, you have made some wrong mistake there. Na? Just look at that. Have you put it in the categorical variables or continuous variables?
Continuous variable.
All the 6.
Yes, sir.
Go to output, pivot tables, chart and table, create cluster membership. This you have checked.
Yes.
Then you have changed this to Euclidean and AIC
Yes, sir.
and reduce determined automatically to 6.
Yes.
Then you should get this output.
Sir, our auto clustering table is different from yours.
How many you have put that 6? Have you put it from 6 or more than that?
6 variable.
No, not 6 variable. Auto clustering, have you changed to this?
Yes, sir.
Have you changed this determine automatically to number of clusters to 6?
Yes, sir. 6.
Then it should be same. Check the variables. Which one you have put in the continuous variables?
कर सकते हैं।
Somewhere some mistake you have put. All the others have got this output.
Sir, can you show the option thing once again?
There is nothing in option. Options, we do not select anything. We do not do anything. Only the output we select these 3. You have selected something in options.
Sir, this to be standardized has to be 6 and assume standardized is 0. And
That is fine. There is nothing to be changed.
But here in my SPSS, it is like to be standardized is showing 0 and assumed standardized is 6. This is the only thing that is different from yours here.
Then you have selected something else. You have selected this assumed standardized, I think.
Sir, please open the output now once.
Yeah.
Output, not this one from that selection table. Option and output option was there over there. Output.
Okay, you are saying this. This. You have selected this, I think. Assume standardized.
Sir, we got, sir, done. We got our mistake.
Clear? You have got your mistake where you have done?
Yes, sir.
Yeah. This is what shows the 3 clusters, the ideal solution here. You can see because the lowest value of AIC is 97.594, which is for 3 clusters. And also distribution, it shows 6, 6, and 8. Same 6, 6, and 8. Is it the same? Because for that we can again go back and check in the data file where it is saved. The results are again saved. So you can see here also. This is the 3 clusters and hierarchical or k-means. This is the 2-step cluster solution. The results are exactly same. The same people are still in the same clusters. Only in this case, again, the name of the cluster is changed, but it is exactly the same results. Those 6, 6, and 8 people are there in the 3 clusters. Exactly same. If you look at the data file, we have saved the data here. So this is the 3 cluster solution from hierarchical. This is the k-means. This is the 2-step. The results have come exactly similar, but in real life, it may not come. As long as it is within the 20%, the change or variation, we can still go ahead with the solution. So there is one more thing you need to check in the output. That is the quality of the cluster. So this 2-step cluster helps you to check the quality of clusters. It is showing the model summary. This diagram is showing you have put in 6 variables and you have got 3 clusters, and the quality of clusters is in the range of good. This is the quality of clustering solution that you have got. But in many times you may not get into the good region. As long as you are into not going into the poor region, but you are in the fair region, you are okay. This shows the quality of clusters. And then these centroid values are exactly the same values that we have got from when we calculated and when we talked about the cluster centers. The same values we have got here, only in this case, they are not rounded off. 3.5 has been rounded up to 4, 1.67 was rounded up to 2, and 5.75 was rounded up to 6. If you check with the final cluster centers, 4, 2, and 6. Similarly, 6, 3, and 4. You can see this is 6, this is 3, this is 4. In the final cluster centered values are coming in a rounded off value. Here, the actual value is being shown. It is exactly the same thing, the mean value for that variable for all the respondents in that cluster. And any doubt till now? So always we start with hierarchical clustering as a method. Once we have hierarchical clustering as a method, we decide on the ideal number of clusters looking at that percentage jump in the agglomeration schedule. And then we confirm it by using non-hierarchical or k-means clustering and check for the quality of the clustering solution using two-step clustering, or you can reconfirm it using two-step clustering, whether the results are good or not. It may happen that in case of hierarchical clustering, when you are looking at that percentage jump in the agglomeration schedule, that percentage jump may not come out to be very, it may come out that for two continuous stages, the jump is so close to each other, the value. Let's say you get a 49% jump and another 49.5% jump in the two consecutive stages. It's very, very difficult for you to decide what exactly is the ideal solution because both are very close to each other. So in this case, what you need to do is you need to go and use or run the k-means or non-hierarchical clustering for both the solution. Let's say you are confused whether it will be a 3 cluster or you are 2 cluster. Go to k-means or non-hierarchical clustering, run it once for 3 cluster solution, run it once for the 2 cluster solution, and then check the final cluster centers. Which one is more varied and which you can name and profile. Naming and profiling is another step which will come to it, but how to do it and all those I will explain to you. But I'm saying when the confusion is there in hierarchical and you cannot decide what is the exact ideal number of solution, you need to go to k-means or non-hierarchical, run it for both and check which one is a better one by using the final cluster centers and the naming and profiling. How to do it, I will explain to you. But sometimes if the confusion is there in hierarchical clustering, you need to check it in the non-hierarchical clustering, and with the help of final cluster center, you need to decide which one is more interpretable and which one will be your better solution. It may happen in some cases. It may happen. It is not always, it may not always happen, but chances are there it may happen. Now, there are different ways of reliability and validity of clusters. One way is you need to, if you have a large amount of data, you can split the data into 2 parts and run a cluster analysis on each of them and see whether the results are similar to each other or not. This is called as split half reliability. It may happen. That is one of the reliability validity checks that you can do. You can check it by having different methods of clusters or different methods of different distance measures and see whether the results are coming similar or not. That is another reliability validity check measure. And the third reliability check measure is basically you have 6 variables here. Remove one of the variables, run the cluster analysis. See what the results are coming or similar or at least close to each other. Put that variable you have removed and remove another variable. rerun the cluster analysis and see, do it 2-3 times and see whether the results are coming almost similar to each other or not. If the data is good and your cluster analysis is everything is okay, they will come close to each other. They may not come exactly similar, but they will come close to each other. So these are the reliability or validity check for clusters. Any doubts till now?
Sir, please
Anyway.
output screen.
Yes, Akash, I am not able to hear you. Your voice is coming very low.
Sir, please come to the output screen.
Okay. Yeah, output. Yeah, tell me.
Sir, in auto clustering, what this negative value shows?
That is change. You don't need to look
What
at this
kind of
change.
change?
You need to look at only this AIC value, absolute values of AIC. See, 104 to 101, it has come down now. So that is what it's showing.
Okay, sir.
That is not the, your criteria is this AIC value. Where it is lowest is your ideal solution. Clear?
Yes, sir.
Yeah. So there is a very important step after this, which is nothing else but what we call as naming and profiling the clusters. Without it, it is impossible to run the, or you cannot say that cluster analysis is complete. Without that, the cluster analysis is not complete. So let us go to that. I have sent you a file which is called as cluster profiling, an Excel file. I will explain it to you, just showing you the file. How to get this output, I will explain it to you. But let us look at what is naming and profiling first. See, you can see the values that we are showing in this 5.75, 6, 3.13. These are the values which are showing the cluster centroid or final cluster center values for each of the 3 clusters. So for cluster 1, the value of V1 and V3 is very high. V2, V4, V6 is moderate or average, and V5 is very low. What is V1 and V3? Shopping is fun. I combine shopping with eating out. Shopping is fun. I combine shopping with eating out. And V5 is I don't care about shopping. So the people who are in this particular cluster, looking at the cluster centroid or cluster center values, you can see these are the people who actually enjoy shopping. And that's how you name the cluster as fun shoppers. That is the reason I have given the name fun shoppers to this group. Similarly, for the second group, exactly opposite. V5 is very high and V1 and V3 is very low. The people who actually don't like or actually hate shopping. So that's why I have named them as apathetic shoppers. The naming of the clusters. Third group, you can see V1, V3, V5 are all moderate, but very high value for V2, V4, and V6. Shopping is bad for your budget. I try to get best buys when shopping. You can save a lot of money by comparing prices. So this cluster or group comprises of people who always look for some sort of what you call as bargains, offers, discounts, etc. And that's why I have called them as budget shopper. Another name can be economy shoppers. So this is what is called as naming of the clusters. And this naming of clusters is always done by using the cluster centroids or final cluster center values. Then comes the profiling part. So before explaining the profiling part, I will show you how I have got these results. So go to the SPSS, go to Analyze, Reports, Case Summaries. The first button under Analyze, Reports, Case Summaries. Now you take all these variables, 6 variables under variables, and along with 6 variables, take also the demographic variables under variables. In this case, you need to take the demographic variables. Here we have only 2 variables, age and gender. If you have more variables like income, education, occupation, etc., everything can be put as demographic variables, which will help you to do the profiling. Now we need to use that cluster solution that you have got as grouping variables. So we have got one solution from hierarchical, one solution from non-hierarchical or k-means, another from 2-step, which you have already saved in the data file. Now, when you are doing the profiling and naming of clusters, always use the value of the solution that you get from k-means or non-hierarchical clustering as your grouping variable. That gives you the best results. So grouping variable is, in this case, we are taking the non-hierarchical or k-means result. Now you see there is a button called limit cases to first. If you have a large data size, you need to remove this option. But here it is 20. So if you remove it, you don't remove it, the results will come same. Take to statistics, add mean. From the left hand to right hand side in the cell statistics. Nothing else is needed. Click on continue. And click on OK. Now, this is the output that you have got. It is showing the case summaries, which is nothing but the cluster centroids, which I have copied in the Excel file. Now, in this case, the fun shoppers was that 8-member group. And you can see the age range is between 18 to 25 in that range. And if you look at the gender, out of 8 people, 7 are females. In the apathetic shoppers group, I don't have any hand in this data. So if this comes like that, who is males or females are apathetic shoppers and all those are fun shoppers, don't blame me. So in the second group, which is apathetic shoppers, you can see the age range is again 18 to 25. And out of 6, 5 are male, 1 is female. And in the last one, budget shopper group, the age range is more than 35 to 45. And there are exactly 3 males and 3 females in this group. So once you have got this result, let me go back to that Excel file. I have copied this result in the Excel file only. So you can see fun shoppers are those people who are in the age group of 18 to 25. You can say 18 to 25 also. And gender is mostly female because out of 8, 7 were females. In that apathetic shoppers group, the age range was again 18 to 25. And out of 6, 5 were male, 1 was female. So it's mostly male. In the budget shopper group, the age range was 35 to 45. And you can see there were 3 males and 3 females exactly. So exactly both male and female. So this is called as naming and profiling the clusters. And none of the cluster solution is complete, or cluster analysis is incomplete without the naming and profiling. But remember, a very common mistake people do is they will use these demographic variables for naming, which is wrong. When you are naming the clusters, you only need to use the cluster centroid or final cluster center values. Once you have named the clusters, then you need to look at the demographic variables for the clusters, and then is called as profiling the clusters. Naming is done based only on cluster centroids, and after you have named them, then only you do the profiling using the demographic variables. The two are different steps. Now, why is this naming and profiling important? Remember what we said initially. What is cluster analysis? Cluster analysis is the method which helps you to find out the segments in the market so that you can do targeting and positioning, the famous STP. Now, once you have got the segments to do targeting and positioning of your product or brand, you need to understand who are the people who are in those segments. And that's why the naming and profiling of the segments is very, very important, because if you don't do the naming and profiling, then you cannot do the targeting and positioning part. What strategies you will take to market to those segments if you don't know who are the people in the segments? The mathematical part of cluster analysis will help you to get what is the number of clusters or segments in the market. But naming and profiling will help you to understand who are the people in those segments. That is very, very important. That is why we need to use this. So, is it clear?
Yes, sir. Sir, could you please show this last procedure of SPSS once again?
Yes,
All the steps.
I will show you. Yeah. You go to analyze, reports, summaries. Select all the 6 variables or whatever number of variables, always as demographic variables in the variables box. Remove these limit cases to first, this button. Go to options, go to statistics, and select this mean from right hand side to left hand side under cell statistics. Click on continue, and the grouping variable should be the result that you have got from your non-hierarchical or k-means clustering as the grouping variable. And once you have done that, click on OK, and that will give you these results. And this results is only I have copied in that Excel file. These are the centered values or final cluster center values, and these are the demographic variables. Based on these centered values, I have named the clusters, and based on the demographic variables, I have profiled the clusters. Clear? Any doubts till now?
Sir, what all variables did we take in this report?
All the variables, including the demographic variables under variables. In this, all the variables, including the demographic variables, come under variables, and the non-hierarchical or means clustering should come under grouping variables. Clear?
Yes, sir.
Yeah. Anything else? Anybody else? Any other doubt? So I will come back to this. I have given you another data set on which we'll run the second data set I have given you. I'll run it again and show you again the same procedure. This time you can do it along with me and tell me what will be the procedure, what will be the interpretation. But before that, we'll take a break and start after a break. We'll take a break of 10 to 15 minutes and start after the break. And any doubts you get in between in the break, You can brainstorm among yourselves and discuss among yourselves. Any doubts you have regarding any of the three procedures, you can ask me after the break. Okay. Yeah. Sorry, it took a bit long. Yeah. So everybody is there. Yeah. So let us start again. So let me open the second file. This is another data. Everyone can see the data, na? Yes, everyone can see it.
Yes.
Yeah. So this is a second data file that I have sent to you. Basically, it is talking of this is a data on this what you call as Nike. It is a data of Nike. So it is talking of the awareness, attitude, etc. measured for Nike. So we have taken data from around 45 people on 5 variables: awareness, attitude, preference, intention, and loyalty on the Nike brand. And also 2 demographic variables are, one is user group, another is gender, basically. So these are the variables which are there in the data file. So all these 5 variables have been measured using very unfavorable to very favorable: awareness, attitude, preference, purchase intent, and loyalty for Nike. And the gender demographic files, gender is female, male, and the user group has 3 groups: light users, medium users, and heavy users. So basically, we'll run the cluster analysis on this data file again. So in the same way, we'll go for hierarchical analysis, like we have done in the last data file. So we'll call those 5 Likert scale variables in the variables. Go to statistics, click on range of solution as 2 to 4, plots, dendrogram, method, words method, and save the range of solutions from 2 to 4. Click on OK. Let us go to the output. Yeah. So here also the 4, 3, and 2 clusters is coming, as I have given the 3 solutions, 4, 3, and 2. So from dendrogram, if you look at 2 cluster solution, it is showing from 0 to 9, H is there, and 10 to 11. Yeah. Let us go to the agglomeration schedule, which will give a clear structure. Yeah. Yeah, tell me.
Due to some internet issue, we weren't able to see the steps that you just performed.
Same
Your
thing.
screen
Same thing. As I have done with the data, same hierarchical clustering analysis, what we have done in, same thing we have done. I've taken the 5 variables, and then statistics, we have taken the range of solutions, plots I have taken dendrogram, method I have taken words method, and save I have taken this range of solutions. Same way and the previous. Only the data set is different. So looking at this agglomeration schedule, can you tell me which one is your ideal solution? Which one can be your ideal solution? Just let me know which is the ideal solution. Look at the agglomeration schedule, the coefficients column. Where is the highest jump? Yeah, let me know. Yes. Which one is ideal solution? 3 cluster, 2 cluster, 4 cluster? Where is the highest jump?
Two clusters.
2 or 3? Read again.
Sir, 3 maybe.
How you are calculating?
We are coefficients. We are looking at the coefficients.
So if it is 3 to 2, it is 413 minus 273 divided by 273.
Yes, sir. There is a
And if it is 2 to 1, that is 2 cluster, it is 604 minus 413 divided by 413. So which one is highest or higher among these two? 273 to 413 or 413 to 604? Which one is higher? Which one is higher? Simple calculation, na? Let me know.
38.
Which one is higher? 273 to 413 or 413 to 604?
Uh, 413 to 604 is higher.
No. Calculate it. How is it higher? Do we look at the
Sir,
absolute value or
38.
do we look at the percentage? What do you look at? Percentage or absolute value? When you look at the jump in the agglomeration schedule, what do you look at?
Absolute value we are looking at, and it is the
No.
ones with.
No, we
And the
never look at absolute value.
We look at percentage, but
So percentage wise, which jump is highest? 273 to 413 or 413 to 604? Which one is highest or higher? This is the first part. If you are not getting it correctly, then the next parts will be difficult for you. What about the others? Everyone else is silent. Only one or two people is speaking.
Sir, can you explain, please, how to calculate that percentage?
273 to 413.
That is what,
Percentage change, na?
sir.
413 minus 273 multiplied by 100 divided by 273. How do you calculate percentage change?
Yes, sir.
What did you did in the last time? 79, 172 minus 79 multiplied by 100 divided by 79. And similarly, 328 minus 172 multiplied by 100 divided by 172. Similarly, here, if you look at the percentage jump, let me know which one is higher. 273 to 413 or 413 to 604. Which one is higher?
207 minus 413. Divided by
Anybody? Which one is higher? What are the others doing, Akash? Preeti, Tarinmay, nobody else is speaking. This is a simple calculation. You should be able to
Sir,
do
it
it in
is-
2 minutes.
Sir, it is 207 minus 273.
No,
If I do for that,
that is 273 minus 207.
273
Minus 207. Why are you doing opposite?
into 100 divided by
207. Why are you going into that? That is a lower jump. You don't need to check for that. Check for 273 to 413 and 413 to 604.
273 minus 413.
No, it is 413 minus 273.
Right. So then it comes into plus value. That's what I'm getting, minus value.
Ah,
So 413 minus 273
273
into 100.
divided by 273. It is coming to somewhere around 51%.
sir, we get 51% for this
273 to
37,
413.
38.
Yes.
Yeah. And
While
the
38 to
31
39, it is around 46.
Yes.
413 to 604. So basically higher is what? 37 to 38. which is 3 to 2, which means 3 cluster is the ideal solution. And the number of members in the 3 groups, if you look at this 3 cluster solution, and if you calculate it, it is 15, 15, 10. It is 15, 15 and 10 in the 3 groups. But a very strange thing has happened in this case. If you can see in the actual data file, you have, if you look at the actual data file, you have 45 respondents. But the clustering has been done for only 40 of them. This is because in 5 cases, there is a missing value. And how do you identify that value? Each of these 5 Likert scale variables are in a scale of 1 to 7. But if you look at the data file, you will see that there are certain values which have been coded as 9. So these 5 respondents have missing values. So whenever you have a missing value, it is coded in SPSS as 9. And that means those respondents will not be considered when you run the analysis. And that's why out of 45, only 40 has been taken for analysis. Not all the 45. Now we have got a 3 cluster solution. Let us go to this next method to cross-check the results of hierarchical with k-means. So you use again all the 5 variables in variables. Go to save and cluster membership options, cluster information for each case, and number of clusters as 3. So here you get the final cluster membership, and you can see 5 of them are missing. That's why it has not been considered. Only 40 have been considered. And this is the final cluster centers. Now, see, there is a difference here. In the case of hierarchical, the 3 groups were having 15, 15, and 10. And in this case, it is having 18, 11, and 11. So where is the difference, or how much is the difference? As I said, 20% or below is acceptable. So 18 minus 15 is 3. 15 and 11 is 4. And 11 and 10 is 1. So 3 plus 4 plus 1, that is 8 out of 40, which is exactly 20%. So the groups are slightly different. Some respondents have changed their groups when we have used hierarchical and k-means. The results are slightly different, but the results are still in the acceptable range because the difference, total difference is 20%, which is the threshold values. So this is the hierarchical or a non-hierarchical or k-means result. Clear or any doubt here? Any doubt is here? Or is it clear? Any doubt?
No, sir.
Fine. So let us go to the third method, 2-step, and again cross-check the same thing. So you have the 5 variables again. Sorry, I've taken it in the wrong place. Yeah, I see. So as per the AIC value, which is the ideal solution? How many clusters? Look at the AIC value and let me know. Where is the value lowest?
135.
Yes, that is for how many clusters?
3.
That is for 3 clusters. So this is also showing 3 cluster solution, like hierarchical and k-means. Let us look at the quality. It is also showing 5 variables, 3 clusters, and quality is in the fair zone. It is not in the good zone, but as I said, as long as it is in the fair zone, it is perfectly okay. But here again, you check. The groups have again changed. Instead of 15, 15, 10, neither it is 15, 15, 10, neither it is 18, 11, 11. It is 19, 15, and 6. So the respondents are grouped differently, or the segments are made differently for each of the 3 methods. Yeah. So let us look at the clustering is fine. 3 cluster is okay. But as I said, when you are doing naming and profiling, we will use the results of always k-means, which is 18, 11, 11. We'll take that and do the naming and profiling of the clusters. So when you are doing naming and profiling, how do you do it? You go to analyze, reports, case summaries. Then what do you do? Analyze, reports, and case summaries. What do you do?
They put all the variables in variable, and then the output of the k-means in the grouping variable.
All the variables in the sense, only the Likert scale variables?
Like a scale variables plus
Or the
we can.
Yeah, in this case, the demographic variables also have to be put. And then what is the grouping variable?
Cluster numbers.
Yes, the result of the means clustering or non-hierarchical clustering is your grouping variable. Then you go to statistics, check the mean industrial statistics, click on continue. If you remove this or not remove this is not a problem because only 40 are there. Click on OK. Now let us name it first. The first cluster, awareness, attitude, preference is high, purchase intention and loyalty is moderate. It's a 7-point scale, if you remember. So awareness, attitude and preference is high, purchase intention and loyalty is moderate. This is the first cluster. Let us look at all the 3 clusters and then we'll try to name them. In the second cluster, these 3, in fact, all of them are quite low. All the 5 variables have a cluster centered values or mean values, which is very low. All above below the midpoint. While in the third cluster, you can see the first 3 awareness, preference and attitude is moderate, while intention and loyalty is quite high. Now, what we have done is, because the first cluster have awareness, preference and attitude high, but intention and loyalty as moderate, we have named it as attitudinal loyals. While in the third cluster, the awareness, attitude and preference is moderate, while intention and loyalty is very high. So you have named it as behavioral loyals. While the second cluster, everything is low, so we have named it as disloyals. So first case, awareness, attitude, and preference is high. Purchase intention and loyalty is low. So we have talked them as name the cluster as attitude and loyals. In the second cluster, everything is low, so that is disloyals. In the third cluster, awareness, attitude, and preference is moderate, but purchase intention and loyalty is very high. So I have named the cluster as behavioral loyals. Attitudinal loyals, disloyals, and behavioral loyals. Is the naming clear? How we have named it? Again, be careful, as I said before also, when you are naming them, you should only look at the centered values and do not look at the demographic variables. Only after you have named the clusters, you need to profile the cluster, you use demographic variables. So in this case, we have named the three clusters as attitudinal loyals, disloyals, and behavioral loyals. So after you have named them, is there any confusion in the naming, or is there any doubt or clarification in the naming? Why I have given them attitudinal loyals, disloyals, or behavioral loyals for the three segments or clusters? Is there any doubt here?
Sir,
Yeah,
this first column is very favorable. What is the
seven,
interpret?
seven, they have given as very favorable and all those. For this particular variable, we have coded as 7. So wherever very favorable is there, that is 7 basically. Is the naming clear? I think they have shared the, yes, they have shared the feedback link, so you can fill it up now or whenever you get time. Yeah. So is there any doubt on how and what or way you have named them?
So based
No,
on
sir.
the mean value.
Yes, the centroid values or final cluster center values. That is the mean value basically. That is the final cluster center value or the cluster centroid values. Using that only we name the clusters. So it is high for preference, awareness, and attitude for cluster 1, and moderate purchase intention and loyalty. That's why it is attitude and loyal. For all the 5, it is low. For second one, that's why it is disloyal. And for the third cluster, the first 3 are moderate, but purchase intention and loyalty is very high. That's why it is attitudinal and loyal. In this way, I have named the clusters. So before we go to the profiling, is the naming clear? So let us go to the, because there is no question, it is naming is clear. And who is this tab 8? Yeah, somebody has logged in as tab 8. Who is that? Yeah, I think that person is not going to answer. Yeah, so let us come to the profiling part. Is there, again I'm asking, is there any doubt on the naming, how you have named it? Okay, nobody is having any doubt. So let us go to profiling. Now, if you go to profiling, let us look at the first one, that is the attitudinal loyals. If you look at profiling, you can see out of 18 people, 11 are male and 7 are female. So majority it is male. But if you look at the users, except 2 out of 18, 16 are heavy users. So this profile of cluster 1, the attitudinal loyals, is majority male and it is mostly heavy users. That is the profiling of the first clusters. So once you go to the second cluster, that is disloyal, you can see out of 11, 7 are female. So majority is female, and out of 11, 9 are light users. So mostly light users and female is the profiling of the second cluster. And come to the third clusters. Again, it is 8 females out of 11. So it's majorly female. And out of 11, you have 7 light users. So again, majorly it is light users. So the naming and profiling is something like this. Cluster 1 is attitudinally loyals, which is mostly heavy users and majorly male. While cluster 2, which is named as disloyals, are mostly light users and majorly females. And cluster 3, which is behavioral loyals, is again mainly light users and majority female. So that completes the naming and profiling of this particular cluster solution. But again, I am saying, repeat, we don't look at the demographic variables while we do the naming. After we have done the naming using only the cluster center or cluster centroid values, we do look at the demographic variables and do the profiling. So this is where we stop, and let me again revise the steps from the start. So once you have the data in hand, you need to do the cluster analysis. First, you run the hierarchical cluster analysis. And you look at the percentage jump in the coefficients column of the agglomeration sheet table. Wherever the percentage jump is higher from stage X to stage X plus 1, stage X is the ideal solution, which in this case was stage 37 to 38. That is, stage 37 is the ideal solution, which is a 3-cluster solution. Then after you have got the ideal solution in hierarchical clustering, you go and recheck it from the k-means or non-hierarchical clustering, which is basically rechecking your results or ideal solution. It came from hierarchical clustering. Here you check whether the final cluster centers are good and what is the distribution. So it may happen, which happened in this case, that the cluster distribution may not be same. In this case, hierarchical cluster has 15, 15 and 10 in 3 groups, while non-hierarchical or k-means has 18, 11 and 11. So as long as this difference is in 20%, it is acceptable and you can go ahead with the solution. And after you have done the non-hierarchical or k-means, sometimes you may not get an ideal solution from hierarchical. Then if you are confused between 2 solutions, you can cross-check both of them using k-means clustering method and try to find out using the final cluster centers or centroid values, which one can be named and profiled in a better way, and that will be your ideal solution. In case it happens that you do not get an ideal solution from the hierarchical clustering. And after that, you can use the two-step clustering to cross-check which is your ideal solution, as well as check for the quality of clusters. As long as it is in the fair range, it is acceptable. And after you have done all these methods, the last step is naming and profiling the clusters. For naming and profiling, you need to use the cluster centroid values. The cluster centroids or final cluster center values will help you to name the clusters, looking at the low and high values of the different variables. And once you have named the clusters, only after that you look at the demographic variables for each of the clusters in order to do the profiling of the clusters. That's the complete stepwise approach of the cluster analysis. So once you have done that, your cluster analysis is complete. So we'll stop here. And if you have any doubts, any clarification, anything, you can tell me. Anything. Anywhere.
No, sir.
Everything is perfectly right. Yeah. So if you have any other doubts, it may happen that you may get a doubt later once you practice and do this method. If you have any doubts in the future, you can always come back to me and ask if you have any doubts. Okay. I think they have shared the feedback link in the chat box. So you can do that, give that feedback. The institute person has shared that, I think. Yeah. So no doubts, no clarification as of now. If you get later, I said, also you can contact me anytime. If you got any doubt, anything later on also. And if there is no doubt currently of any of the things regarding the process, regarding how to run it, regarding the interpretation or anything, if you have any doubt, you can ask me now. If there is no, we'll sign off. Later on also, if you had any doubt, anything, you can ask me. Okay. So we'll sign off now. And if some of you are doing my next workshop, which is on EFA and CFA, which is next week, Friday again, we'll see you again in that workshop. If some of you are doing it. Because I can see some repetition from my previous workshop on discriminant in this workshop. In fact, I have 3 more workshops coming on. One is on EFA, CFA. Another is in path analysis and the ACM part. Another is moderation mediation in ACM, which are the 3 more workshops coming up. One is next week and the other 2 in October, 14th and 21st October, I think. Okay, so if you don't have any doubt or anything, we'll sign off here. And as I said, if you have any doubts in the future also, you can ask me. Okay. Yeah, hoping to see some of you in the next workshop again. So we'll see end of the workshop as of today. All the best in your research journey. And hope that it helps you in your research. Yeah. Bye.
Bye, sir.
Yeah.
Bye, sir.
Yes. Okay. Bye.